So in this video, I'm going to go through mole relationships in chemical reactions. Now, starting off looking at a reaction between silver and sulfur. Here we have Ag for silver, S for sulfur, and we're making silver sulfide. You notice the equation is already balanced. So our mole ratio is 2 to 1 to 1. Now, how are we going to be interpreting those coefficients? Well, the first way we're going to interpret them is in terms of moles. So I could say then, 2 moles of silver react with 1 mole of sulfur to produce 1 mole of silver sulfide. And this is what we're going to be using today to solve our questions. But just to carry on through this so you can see how we can use the coefficients. Once I have moles of everything, I can convert them to grams by looking up their atomic masses. So we have 2 times the atomic mass of silver, 1 times the atomic mass of sulfur, and 1 times the molar mass of silver sulfide. Now if I continue on with the math, I wind up getting 247.9 total grams of the reactants, and on the right, the same mass for the products. And this is called the law of conservation of mass, or matter. And this is what we use then to determine how much of a product we can make if we have a different amount of the reactant. And this really then is going to be our recipe. So every time you balance an equation, you discover the mole recipe for the reaction. So let's take a look at a few problems as we go through these. All right, the first problem, how many moles of chlorine gas would react with 5 moles of sodium according to the following chemical equation? And you notice that the equation is already balanced, 2Na on both sides, 2 chlorine on both sides. I'm going to copy out the given information first. 5 moles of sodium, X moles of chlorine. I'm going to write down then the mole ratio from the equation that involves these two. So the mole ratio is 2 moles of sodium to 1 mole of chlorine. Now I'm going to be writing this mole ratio in the form of a fraction. It's really a conversion factor. So you notice how I set it up. I'm starting with my given, my 5 moles of sodium, and I have my moles of sodium down here so I can cancel it. So there goes the moles of sodium. And when I do the math, I'm going to get moles of chlorine for an answer. So it's really just 5 divided by 2, and I get 2.5 moles of chlorine. So you notice then that the ratio 2 to 1 is maintained with the 5 to 2.5. All right, let's try another reaction. Okay, question is how many moles of sodium chloride are produced when 2.5 moles of sodium react? Again, I need my balanced equation. I'm going to write down the given information first. And then I'm going to write down the mole ratio that involves these two. So the mole ratio is a 2 to 2, which could be reduced to 1 to 1. So let's see how we'd set this up then. So I'm going to start off with my given information, which is the 2.5 moles of sodium. And here's my conversion factor now. So you can see everything is going to cancel. The 2 moles of sodium, that'll cancel out. We'll get that mole of sodium gone there. I cancel this 2 with that 2. And then when I do the math, I get 2.5 moles of sodium chloride. So the ratio is 2 to 2, which is the same as 1 to 1. And you notice 2.5 to 2.5. All right, let's try a couple more. Now I'd like you to try this one on your own. Just go through the question first. How many moles of sodium chloride are produced when 4.2 moles of chlorine react? And you can see the equation, 2Na plus Cl2 yields 2NaCl. So write down the given information, the mole ratio, and then your solution. So you want to pause the video at this point and then come on back and check out the solution. All right, here we go. The given information, 4.2 moles of chlorine, X moles of sodium chloride. Mole ratio, 1 mole of chlorine to 2 moles of sodium chloride. We set up our solution. You notice that we can then cancel. Moles of chlorine cancel out with moles of chlorine. I do the math. I get 8.4 for an answer. And that makes sense because that is 8.4 to 4.2 is that 2 to 1 mole ratio. So how did you do? All right, let's try one more. How many moles of Fe2O3 can form from 6 moles of oxygen? So again, try this one on your own, then come on back and see the solution. Okay, here we go. Given information, 6 moles of oxygen, how many moles of Fe2O3? Mole ratio, 3 to 2. So you can see the 3 to 2 mole ratio right up here. Now I'm going to start off with my 6 moles of oxygen for my given information and set up my solution. And you notice that I can cancel out moles of oxygen. That lets me know I've set it up right. I can divide 3 into 6. That would give me 2. And then multiplying across, I get 4 moles for an answer. So how did you do? I hope you did fine, got them all right. This is the end of the video.